Okay. But if you're interested in learning how to format this properly and as nice as I have, we can talk about that at the end of the semester. I will share my script and source code. And this was produced by a program, not, I didn't type it. I mean, I typed a program to produce something like this. Any other questions you have? Okay, that being said, let's move on. So today we're gonna start something completely new, okay? And this is not something we will cover in midterm, but it will come up in the final. By the way, the final and midterm are disjoint, meaning that final will cover everything starting from today. And everything before today will not show up in your final. So you really need to prepare two subsets of materials for the in terms of the two tasks we have in this course. Okay. So as far as midterm is concerned, this will not be tested. But that being said, you still need to pay attention because this will show up in the final. And plus, this is a really important topic in refining your schema design, as you will see in a minute. Why it's important for refining your schema design. Okay, today we're going to talk about something called functional dependency. And this will build the foundation for the next topic, which is normalization. Okay. All right. So what is functional dependency? So if we step back and look at where we are, so we basically talk about requirement analysis. That's like analyzing your user specification and coming out with the ER model. That's what we call conceptual design. And then we have the logical design, which is translating ER to DBMS. That's basically what you've been working on in your homework 1 and phase 1. And essentially what you're doing now in your phase 2 of your project. And then we kind of talk about, once, assuming you have a nice design in place, how do you manipulate data and retrieve data out of it? That's the discussion on relational algebra and SQL. Now let's go back to this schema design a little bit, which is, okay, suppose I follow all this step. I follow the conceptual design, I know ER really well, and I do my conversion properly, meaning given a ER design, I convert that to relational model, following all the rules and procedures we talk about. Are we getting a really good design out of it? The answer is yes, for the most part. You will get a really good design out of it, but not always. Not always. Why is that? Because there are additional business rules that cannot be captured by those things we have already talked about, such as key constraint, like one-to-many mapping, many-to-many, and one-to-one, and total participation. In ER, you only have those two types of constraints you can capture, right? One is what we call key constraints, many-to-many, one-to-many, one-to-one mapping. The other is total participation constraint. Those are the only two types of constraints you can cover in a ER, right? Is that right? So, what if you have more sophisticated? Sorry about that. Let's get what if you have more sophisticated constraints you want to check? That's not, you cannot catch that using just those things I talk about, but we already talked about. Okay, that will come up under this topic called schema refinement. I will give you a specific example. You might wonder what's beyond that. What kind of constraint I cannot capture in my ER that we have not already covered. Okay, I will show you a few examples, then we'll go from there. Okay, that moves with the discussion on functional dependency. So before I do that, there's this general principle which you may not comprehend this 100% now. But just keep this in mind. This is like a mission statement, right? Oftentimes you embark on a mission without fully understanding what that mission is about, and you will have a much better understanding of that when you complete that mission, right? So take that kind of approach by looking at this. So for now, just remember this. This is our mission statement, which is to say redundancy is at the root of several problems associated with relational schema. Redundancy introduced redundant storage, and it also introduced insert, delete, update anomalies. I'll give you one simple example of this. Like think about the student course and the enroll schema. That simple example. I have a student table, I have a course table, I have another enroll table showing who has taken what class. And that's my table setup, and translating back to ER, that's like a student entity set, a course entity set, and maybe a manage many mapping between the two. Henceforth, I will have an enroll table for that manage many mapping. And if you follow the discussion all along, for that enroll table, what would you have? You would have student ID, course ID, and whatever relationship set specific attributes, such as the grade the student received for a particular course. That's what you will have for that enroll table, is that right? You will not store student name, login of the student. Similarly, the course name, the time of the place the course meets at, and the time the course will be conducted. You will not store those information in the enroll table. Rather, those will be stored in the student and course table respectively. Does that make sense? Of course, you can, if you want to, take the student name and course name, place that into the enroll table if you want to. But when you do that, that introduces quote-unquote redundancy. And you may wonder, what's so bad about having redundancy? For example, if I want to know the name of the student who have received an A in some course, if I do have that redundancy, what did you get? Well, you get query level efficiency, meaning that you simply do a select statement from the enroll table where grade equal to A and per that out student name, you're done. Versus the original design without redundancy, meaning you do not copy student name into the enroll table, what would you have to do in that case? You would have to do a join between enroll and student in order to get the student name who have received A. Do you see the difference of the two? So seems like redundancy is our friend, because join can be expensive. In the worst case, join is like a cross product between two, and we set this amount of times. If you do this naively, you end up with n squared cost if each table has roughly n records. Does that make sense? So you may wonder why we are willing to take a potentially really costly operation that's as expensive as n squared versus having some level of redundancy and be done with it so that my query is linear time. Because now if I have that name in the enroll table, I avoid doing a join completely. I end up with linear cost. That make sense? There are two comments or two reasons why people don't do that. Okay, first of all, efficiency. Join in the worst case can be n squared, but in reality, 99% of the time is just almost as good as linear operation. And how to do that, we will talk about that later on. If we have time, we will dive into the engine a little bit and look at how join queries actually is handled. But that's given if we have time. Okay, but that's one comment number one, meaning that join may not be as expensive as you thought. Okay. Second point, if you take the approach that have redundancy, what you end up with is this insert, delete, update anomalies. What do I mean by that? Suppose you want to change the student name. I know you don't change your name that often, but assuming it's an attribute that you may change the value for. Okay? What will happen? Well, not only you need to change the name of the student in the student table, which affects a single record, because each student appears only once in the student table. Now, with this having redundancy approach, you will have to update potentially many times, many records for each record that student has taken a course. If this student has taken 20, 30 courses, or 60 courses, you will need to update 60 times in the enroll table for that same value. Does that make sense? And these many updates may potentially go wrong. Why? For example, you have to update 60 records from the enroll table to update to the new name for the student. Let's say you have finished updating 30 of them. And then, it's really a bad day for you, and server loses power. Database goes offline. What you end up with? You end up with inconsistency for that student's name in the enroll table. Does that make sense? You have 30 records with this name A, and another 30 records with the old name for the same student. Does that make sense? And that's what we call update anomaly. Whereas if I have only the student ID in the enroll table and the name attribute is in the original student table, I will not have this issue to worry about because I'm updating a single record. Either you make the update or you do not make the update. Meaning that either you got, in the case of system failure, either you have the database still with the old name of the student, in which case you can easily verify and reapply the update when the system is back online, or you have finished the update before system goes down, and you already got the new name in the database. And you do nothing about the enroll table because you are referring to the student record using student ID, which is a constant, never change. So that's a simple example why redundancy is evil, why redundancy is bad. Okay? There are more examples as we go along. I will motivate this observation using a couple more examples. So now, that being said, schema refinement refers to what if you start with a design that has some level of redundancy, like student, enroll, and course. In the enroll table, you have the student name. You may wonder, why I have that in the first place? Well, you never know. Maybe somebody else was the DBA before you become the DBA, and he or she made a bad choice, and that's the design you have. And in a simple case like that, you can just look at it and figure out, okay, this is a bad design. I'm going to remove name attribute from the enroll table. But with a complex database with tens or even hundreds of tables with complex relationships, is there a more systematic way you can check this? Rather than relying on some person's expertise or some person's eye to catch this somehow, magically. Right? So that's kind of what we're going to talk about. It's that systematic way of checking such quote-unquote bad designs that leads to redundancy, various degrees of redundancy in your database. Okay? So that's the topic of decomposition, which will come up later on. Okay? So before we do that, we first talk about this concept called functional dependency. And that forms the foundation of finding out the redundancy and to perform schema refinement in your database. Formally, a functional dependency, X determines Y. What's X, what's Y, by the way, here? X and Y are both symbols representing either a single or a subset of attributes from your schema, from the same schema R, from the same schema R. So X and Y may not necessarily be a single attribute. It could be a set of attributes from the same schema R. Okay? And we claim X determines Y holds over a schema R if for every allowable instance of R. First of all, what do I mean by allowable instance of R? Because R is the schema, right? There could be numerous possible valid instances of R. Think about R as the student schema. You can have a valid instance of the student table with a single student record. You can have another allowable instance with two student records, and so on and so forth. What is some example of disallowable instance? Well, for example, if student age attribute is integer and you have an instance with one student record where age value is a float number, 17.5. For example, somehow you want to capture the fact that this guy is between 17 and 18 years old, and roughly 6 months past his or her last birthday. You want to do that? That's fine from the application level point of view, but if your schema has age as integer, that's disallowed. That make sense? That's an invalid instance, for example. Okay. So for every allowable instance, meaning that you are dealing with only valid instances, for every such instance, there are many, many possible such instances, but for any such instance, given any two records from small r, so small r is a particular instance conforming to this schema, capital R. Now, for any two records from that small instance, if the projection of X on those two records equal to each other, then the projection of Y must be the same. And when this is the case, you declare X determines Y. When this is the case, you declare X determines Y.
Does X have to be a key or something?
No, it doesn't have to be the key.
So how would it, if X was the
So I will give you some examples. Okay? So X doesn't have, that's actually a very good question. Neither X nor Y have to be a key of your schema. In some cases, you may have non-key attribute that this still holds. So let's look at a special example. Suppose I have this employee, hourly employee table. We saw this before, right? In the ER discussion, where we have SSN, name, lot, rating, wage per hour, hours per week. Because the hourly employee, I want to remember the key of each employee record, which is the social security number. I also want to know the name, the lot. Let's say suppose that's the parking lot for this employee, right? I assign a particular parking lot for this employee. By the way, parking lot is not a particular, suppose it's not one particular car space, but it's a lot, right? Like the lot in front of building 31, the parking lot in front of building 32, that's what I mean, okay? Within a particular lot, you can park anywhere. But you have to park in that particular lot. Like, you guys have the permit U, I have permit A, where A lot and U lot. And you cannot park in A lot, but you can park anywhere within the U lot, right? So that's a real example that you can connect to. And we also have rating, wage per hour, hours per week. What does it mean? Well, rating, let's say it's a 1 to 10. I give a rating for every hourly employee, and let's assume, and in most cases, the rating of an employee determines how much you pay him or her. The higher the rating is, the higher the wage per hour is. But have no relationship with hours per week, because that really depends on how much time this employee can commit to working for you. That varies from person to person and has nothing to do with rating nor hour per wage. Is that clear? So that's kind of the setup. This seems like a perfectly okay schema. There's nothing wrong with it. Okay? Until we dig deeper into this. And for the ease of discussion, sometimes I denote a relation schema by listing the attributes by using the capital letter of the first letter of each attribute. So this relation becomes SNLRWH. I capitalize the first letter of each attribute, and that's my shortcut in referring to this particular schema. Not only I get the schema, but I also get each attribute out of it. So that's just a shortcut to represent this particular schema. So it's really representing a set of attributes SNLRWH. And we also can refer to the same set of schema by simply using the name of the schema. So both of these are interchangeable concepts in the context of our discussion. What are some functional dependencies on our employee using this definition of functional dependency? Okay, X determine Y. Okay? Take a good look at this definition and come back and think about what are some functional dependencies. A trivial functional dependency that you always have is okay, let's ignore the R determines W thing. The first functional dependency you have is X social security number determines everything else. Why is that? Why we have this function? That's why I said earlier when you asked, we only have key attributes in functional dependency. That's a good question because keys automatically give you functional dependencies. Why is that? So why X determines S N L R W H? And this, is, by the way, is the same to say S determines every one of them, every single one of them. So these two are equivalent. And later on, I'm going to give you a formal argument why these two are equivalent. But for now, intuitively, if you determine everything else, it's kind of like you determine each one of them. It's something like you have a key. You can open 10 different doors to 10 different lecture rooms. That's the same to say you can determine lecture room A, you can open lecture room B, you can open lecture room C. Repeat that 10 times. Intuitively. Well, we need a formal argument later on, right, to prove this formally. But intuitively, that makes sense, right? If you have a key that opens 10 different doors, That's the same to say I can open door A, door B, door C 10 times. Intuitively, these two are equivalent. Right? So why? Well, why we have this? Let's look at the definition of functional dependency and try to kind of understand why that's the case. Functional dependency says if x determine y, then for any R from schema R, okay, so any R from schema R, then any T1, T2, two tuples from that small instance R, if projection of x on T1 equal to projection of x on T2, then projection y on T1 must equal to projection y of T2. So that's the definition of functional dependency, where R is a valid instance of R. And T1, T2 are any two records. X and Y are subset of attributes. You follow this? That's the definition of functional dependency. I'm doing nothing fancy, but just replicating that particular slide so they can make reference to this. Okay? Now, with this being said, why this is a functional dependency? Why these are functional dependencies? Let's look at one of them. So I'm going to erase all of the rest to make some space for me. Because if you can argue for one, the rest become trivial. It follows the same symmetric kind of argument. Let's look at why S determining n is a functional dependency. So in this case, what's my x? That's my x. This is my y. Here, x and y happen to be a single attribute. And what's my r? This whole thing is my r. Of course, don't confuse this r with this r. This r now stands for the schema. This r stands for a rating attribute. In order to, let's say I differentiate that using this calligraphic r. Okay? So far so good? This is my r, this is my x, this is my y. Why this is a functional dependency? Let's check by just looking at the definition. What it says is, let's look at any instance from this schema R, meaning that any instance you can think of. In other words, any set of hourly employee records you can come up with. Any set of hourly employees you can come up with. And now let's look at any one such set. Let's say 10 hourly employees I have. I look at this set. And any two records. So what are these two records now represent? Can you tell me? In this particular case, what are those two records represent? Under this discussion we're having right now, what are those two records represent? Do they represent a department? Do they represent an employee? Do they represent what?
Hourly employee.
They represent two particular hourly employees. But the trick is you are not limiting what are those two hourly employees, any two hourly employees. That's essentially what we are saying. From this particular instance R. Does that make sense? So the hold, so whatever I'm about to tell you must hold for any two hourly employee for this arbitrarily chosen instance. In order for what I say to be true. You cannot look at just two of them and make an argument. You have to make this argument true for any two choice that somebody will choose for you. Okay, that's the key. So this represents nothing else but two hourly employees. And what I'm about to show you is that if projection of S of T1 equal to projection of S of T2, then projection of N of T1 must equal to projection of N of T2. So that's just copying the definition of functional dependency, applying that in this particular instance. Do you follow this? Now let's read this in plain English. What does that mean? In plain English, what that means is, if I have two employees arbitrarily chosen, if their social security number, S stands for SSN, right? And N stands for number of hours. per weight, I think, right? Oh, name. Okay, all right. Then it's name. It's actually a simpler example, okay? So I put out, what I'm saying is, if you give me two records, and if their social security number are the same, then their name must be the same. If that's the case, S determines M. Now you guys understand, right? Not plain English, everybody can understand. Is that true though? And this actually is a subtle example, right? First of all, will this ever be will this ever hold? For, okay, I have to quantify this. For T1 not equal to T2, for two different records. Will that claim ever be true?
Not if you're dealing with the key.
Not if you're dealing with the key. Excellent. This actually will never be true. It's kind of, I'm making a statement saying that, I don't want to sound like, let me give you an example. Okay, I will fly to the sun. Okay, that's like suicide, by the way. If Earth blow up tomorrow, you will think I'm lunatic or crazy, but I'm not, because think deeper. I'm making a statement on a condition that will never be true. So you can say whatever you want. Does that make sense? Yes? I will fly to the sun as soon as tomorrow. It's Earth blow up tomorrow. You think I'm lunatic. I'm not. I'm making that the action sounds like crazy lunatic. You're committing a suicide. But the thing is, the condition that I'm going to take that action is never going to be true. Okay, so means there is maybe one out of billions chance the Earth will indeed blow up tomorrow. But in that case, where I fly to doesn't matter. I mean, rather, in that case, I would prefer to have the option of flying to the sun rather than staying on the Earth. But I'm still okay. I'm actually being kind of smart, not being a lunatic. But you see my argument, right? So he made a really good observation, which is this actually will never be true. So you don't have to even worry about checking the second condition. Obviously, the name of those two records, it's possible they're the same, and it's possible they're not the same. But you don't bother with that at all, because to begin with, the two social security numbers will not be the same. So you don't really care whether the names are the same or not. And this is always true. Do you follow this? It's a subtle. Of course, you may argue, if T1 and T2 are two symbols, what if they refer to the same record? What if they refer to the same record? In that case, S determines N is always true. In fact, any is true, right? Because if you're referring to the same record, then if social security number is the same, they must be the same by default. So the trick is functional dependency holds for arbitrary selected two records. So you cannot manually say I limit myself to the same two records. No. Okay? It must be true for arbitrarily chosen two records. But in that case, the first condition is never going to be true, so that you don't even have to worry about checking the second condition. So this automatically is true all the time. Henceforth, S determines everything else, because you can apply the same argument on each of other attributes and use the same argument, exact same argument, to prove this. So this is what we call trivial functional dependency. It means that this trivially holds on any schema, without even looking at the business rules, without looking at user specification. A key of a schema determines all attributes of a schema. This is trivially true for arbitrary schema. This is what we call trivial functional dependency. So far so good? Now let's look at if we have trivial function dependency, we must have non-trivial function dependency, right? The point that we introduced the word trivial here, right? So what are some non-trivial function dependencies? Those are the interesting cases, right? Trivial cases like Bama beats whatever, right? That's trivial. Maybe you disagree with me, but so far the data supports what I explained, right? So that's not interesting. I actually lose interest in watching those games anymore, right? So let's look at some non-trivial cases. Do you have some questions, bro?
Yeah, so
can you speak louder? Key one determine key. Oh, yes. This still holds regardless whether n is a key or not. In my argument, in the entire argument I made, I made no dependency on the fact that n is the key, right? So whether n is the key or not doesn't affect my argument, doesn't affect my proof. So this will hold regardless. Okay. All right. Now let's look at a non-trivial function dependency. Let me give you one example. Let's say, using the earlier example, I already told you that rating determines how much you pay this person. I mean, in fact, you better insure this as a corporation, right? Otherwise, you may end up with a lawsuit, discrimination, right? You are giving the same rating for the two employees, and you give them different pays. That make sense? You don't want to go down that path, right? If this ever found out, then you are in big trouble. You are paying a lot of penalty fees. Right? So you want to make sure this is the case. That's an example where function dependency is really important, right? Right? Rating determines wage. Of course, people can still abuse the system, right? Even if we, as database designer, we make sure all this in place. What's the way to abuse the system? Well, simply give them different ratings. You still can pay them differently. You give them different ratings for possible different reasons. On the valid side, they really deserve different ratings, right? On the invalid side, they actually deserve different ratings, but you want to pay them differently, and you don't want to be sued for discrimination, so you give them different ratings to begin with, right? We, as the technical side, we can address the first issue, which is if you do give them the same rating, you better pay them the same. But we cannot address the second issue. The second issue becomes a social problem, right? Not an engineering problem anymore. Okay, but let's say we do want to enforce this, at least to the very least, rating determine wage. So what does that mean when we say rating determine wage? That's a function of dependency, right? Let's just apply the same process. We just did. This is your x, this is your y, and this is still your calligraphy R. So good? What does this mean? For any instance R from this schema R, calligraphy R, and any two records T1, T2 from small instance R. Meaning that for any set of hourly employees you have, that means this must be true throughout the course of your corporation, right? Because initially you start with 10 hourly employees, that's one instance. 10 days later you add another 5, so you have 15 hourly employees. That's two different instances you have, two different small R's you have. I'm choosing any of the R's you have throughout the course of your database. So this must be true for the entire duration of your database. And once I select a particular instance, I will have the choice to select any two records of it. So any two employees, hourly employees from that instance. Does that make sense? Okay? So this represents two hourly employees. What does this mean? That means if projection of R rating on X equal to projection of rating Y, then projection of wage of X must equal to projection of wage of Y. Note that I'm simplifying. This is the hourly wage, right? Because wage can be confusing. Are you talking about total compensation or just hourly wage? Because total compensation can still be different because they may work different number of hours. Okay, so I'm just simplifying. This is hourly wage, right, to be precise. So that's what I'm saying when I write R determines W, which makes perfect sense, right? Any two records, you look at them, if the rating value are the same, the wage column of those two must be the same. If that's the case, rating determines wage. What if you have a violation of this? If you have a violation of this, meaning R does not determine wage, R does not determine W. What that means? That means you will be able to find at least one instance. Maybe out of the million instances, there's only one instance, and in that instance, there are only two records that this does not hold. Still, that's not okay. Because as long as you found one instance, and there are only two records in that instance where rating value are the same, wage is different, you find at least one case of discrimination, which is not okay. That make sense? Like you have a database of all people. You say, I will not discriminate based on race, based on background, everything is fine. Until one day you have Martian in your database. You have a single Martian in your database. And you determine to pay that Martian a little bit higher. You say, I'm not discriminating against anyone out of the million employees I have, except this one Martian. It's not okay still. That's what function dependency says. You say, wait a minute, he's Martian, but doesn't care about that. Right? That make sense? So this must be true for any instance and any two records from any instance you can have. Yeah.
So if there's like a functional dependency, does that mean there has to be like a function that maps like from one to the other?
No. So even though we call functional dependency, but this actually is not a function. It's not a mapping. Function, mathematically, what's a function? Function is you have an input space, you have an output space. And you are defining a mapping from here to here, typically written as f x over y. You draw this geometrically, this is ux, this is y. Any kind of curve define a function. We're not doing a mapping. Note that we're not calling this function dependency. We call functional dependencies. We're not defining a function. We're not defining a mapping of whatsoever. We're simply stating a fact.
But doesn't there have to exist, like, for it to hold? Wouldn't you have to have some sort of mapping?
No, there's no mapping. All I'm saying is, if you have two records, the projection of x, if the projection of x are the same, projection of y must be the same. That's all I'm stating. I'm not defining any mapping whatsoever. Of course, I see what you're saying. This implies, okay, I think I get what you're saying. This implies not a mapping, but an association of particular values. What do I mean by that? If I have x determine y in place, like rating determine wage in place, now assuming you have a record with rating 5 and hourly wage $20, okay? I think what you're saying is, now what if I insert another record, another employee with rating 5? Do I have any choice on the hourly wage? You don't. At that point, you are binding to 20. You cannot set any value other than 20 for that second record with rating equal to 5. So it's not a mapping, it's an association. Why I claim it's not a mapping? Because a mapping means it's deterministic, meaning if it's 5, it always must be 20. That's a mapping. Association simply says if x are the same, y are the same, I can perfectly change this for all those with rating equal to 5. For example, for now, 5 is 20, but later on, I can decide, you know what? We have a tax cut, right? As far as I know. No? I'm going to raise the hourly wage. 5 is no longer 20. 5 now, good news, $21. So seriously, I mean, come on. If I'm the boss, you give me a tax cut of $10, I give $1 to the employee back. And that's what will happen in the real world. Trust me. I'm not. By the way, don't take my my example of my political views, right? I'm actually, I don't want to go down that path. Okay, just forget, this is a bad joke, but I'm not saying. Maybe an employer will say $5, waiting $5, $20, I now pay $30. That's probably possible, right? So so don't hold me against any. It's not associated with my political views. Okay, so that's the difference between association and mapping. Do you follow me? Right? Mapping is deterministic, right? If you say 5, rating 5 pays $20. So if it's rating to wage, maybe it's the curve most likely is a monotonic function, right? Most likely, right? Most likely is a monotonic function. Right? So mapping means that if it's 5, always 20. Association means that currently 5 is associated with 20 for all of them. So if you have another 5, you must set the value to 20. But you can later on change this any way you want. You can change this to all 5 become 25, or all 5 become 30. Right? So that's the difference between mapping and association. That being said, let's so we already seen a trivial function dependency, which is if you have a key. We said that's a trivial function. There's another type of trivial function dependency, which is an attribute always determine attribute itself. Why? Because you're claiming, let's do the same exercise, right? Lot, determine lot. What are you claiming? You're claiming for any two records, if the projection of the lot is the same as the projection of lot, then the projection of lot is the same as projection of lot. Like you are kind of repeating yourself, but nevertheless it's always true. You look at two records, if their lot value are the same, then their lot value are the same. That's what you're claiming. Of course this can't be true for any two records. You may argue, what if their log value are different? Well, it doesn't hold. You don't have to check the then statement. Like if tomorrow is sunny, I'm going to play tennis. So you look at the weather tomorrow is sunny, you know I'm going to play tennis. But if tomorrow is not sunny, what can you claim me? Am I playing tennis or not? Be careful. It doesn't mean I will not play tennis. You simply do not know. Because I made a statement that if it's sunny, I play tennis. I said nothing about what if it's not sunny, if it's like earthquake or raining or whatever. I may still be playing tennis. Or may not. I don't know. You know nothing about that. It's like when you sign contract, right, you have to be extra careful. For example, you work with a real estate agent. He or she said, if this house is for 300K, you will buy the house. You sign it, and later on, the price come back to be. Okay, let me make it even better. If this house is less than 300K, you will buy the house. You sign this contract. Later on, the price come back to be $1 million, $500,000, let's say. Can you sue the agent for it? Who think you have a case? Who think you do not have a case? Do you follow my example? If this house is less than 300K, you will buy the house. You sign it. You say, okay, on that condition, I let the agent make decision for me. You can do whatever. And the agent come back with a contract saying that this is legally binding to you now. Sales price $500,000. You say, wait a minute, I didn't sign that. Do you have a case? Or you do not have a case? You do not have a case. You will lose. Why? The contract says, if it's less than 300K, you buy the house. It says nothing about what if it's above 300K. You didn't say, if it's more than 300K, I will not buy the house. You do not have that term in the contract. So when the price is above 300K, the agent can do whatever, legally speaking. That's a trick. You guys probably sign contract like this all the time. Go back, review. I mean, insurance companies play this trick all the time. Real estate agent, with all due respect, if you guys have real estate agent working in your family, they do this trick all the time too.
Does this say?
It's like me saying, if you come to my class, if you work hard, you will get A. You think that's a really nice professor. Oh, right? If you work hard, you will get A. No, I would not. That's a bad condition for me. No, I would not say that. I would say, if you work hard, if you do not work hard, you will not get anything lower than B. That's a really nice professor, right? Even if you don't work hard, you will not get anything less than B. But that doesn't mean if you work hard, you will not get a grade less than B. So don't get yourself tricked. You will think, even if I don't work hard, I will get better than B. So if I do work hard, I will get definitely better than B. No, you may actually get C minus. Does that make sense? You follow that logic trick? I'm tempting to do this, but like if I want to increase the attendance of my class, it's like you don't work hard, you get B, at least B. So I will get a lot of students, but that doesn't mean if you work hard, you will get better than B.
So if the rating implies the wage, why not then just take the rating and the wage and put them in their own?
Okay, excellent. You are jumping ahead. You are identifying the redundancy problem. You are thinking about how to fix that. I will talk about that in a minute. So in our life and in database in particular, you have this kind of tricks all the time, and pay attention to this when you sign a contract. Think about functions, the discussion of function dependency we talked about. Do you follow those examples I talked about? Okay, very good. Let's look at what he is suggesting. What are you may argue, fine, it's like a brain teaser, big deal. Okay, you got me, you tricked me, so what? Okay, let's look at so what. Let's look at what. Okay, what will happen if you do not catch those kind of tricks? So let's say we have R determined W. Look at this particular instance, do we have that? Yes, we have this, right? For all reading equal to 8, which is 10. For all reading 5, reading is 7. By the way, before I show you the next slide, is it okay for me to do something like this? If I have reading determined, why can't I change this? Okay, Microsoft is working. Okay, let me say, how do I change this? Okay, let's just imagine in your mind. On this particular case, is it okay for me to do the following, which is I change those two records with rating equal to 5 and change the hourly wage. Currently is 7, right, for those two records. I change them to 10. Is that okay? How many of you think that's okay? How many think that's not okay? How many think that's okay? Can you tell me why that's okay?
Because if the rating determines the wage, you're changing all of them, so.
No, that's not the reason why I think it's okay.
This is not okay because 8s are 10
This is
as
not
well.
okay, you're saying.
Yeah, 8s are 10 as well. So then you would have ratings 5 and 8 equal to 10, which is not okay.
Okay, now it's becoming interesting. Now let's have a debate.
Let's say that it's okay because you have nothing constraining you from changing it.
Yeah, to elaborate what he says a little bit more, always says if your ratings value are the same, then wage value are the same. If your rating value are different, what can you claim about the wage? Nothing. This goes back to the example I just made. I play tennis tomorrow if it's sunny. You can hold me accountable if it's indeed sunny and didn't play tennis. But you can do nothing about me if the weather is not sunny. If rating are the same, wage must be the same, which I have, right? All the rating equal to 8, currently value is 10. All the rating equal to 5, wage is 7. But if I change those rating 5 to 10, okay, the salary to 10, you cannot come back and argue against me because what I said is if rating are the same, then wage must be the same. If rating is different, I said nothing about what I would do. The wage can be the same, the wage can be different. I can do whatever I want. Do you follow that argument? That's something you want to pay attention to. Like if you sign up for a company, they shows you currently what they pay. They also tell you in our company, rating determine wage. And this is our current scheme, how we are paying our employee. You look at this, you think that's fair, right? Rating 5, you pay 7. Rating 8, you pay 10. And they are telling you also, with your experience, I'm going to put you rating 8 in category 8. And your friend, who is my nephew, okay, I'm going to pay him at rating 5. You think that's a perfectly, and I suppose you are 5 years more experienced than that nephew guy. You think that's fair, right? You got a higher rating, you got a higher pay. And rating determines wage. You sign the contract with the company. As soon as you sign the contract, you know what happens? They change the rating, they change the wage for rating 5, not equal to 10, to 15. Outrageous. Can you do anything about it? Huh? Well, you can do one thing, you can quit. But you cannot sue them. Does that make sense? So all they said is rating determines wage. If rating is the same, yes, you're going to be paid the same. But if it's rating different, who knows what they're going to do. So don't be tricked by this kind of things, right? When you sign a contract, look for those things. All right, so that being said, let's get back to the real problem. And that's a side note you want to pay attention to, right? What's the problem due to rating determined wage here? What's wrong with this design?
So like your wage is duplicated, like because you're only gonna have like 10 or 7 or like.
Yeah. So one obvious problem is you're duplicating this association, not mapping, association between rating and wage. Imagine you have, this is a small database, right? But imagine this is Google or Microsoft or IBM. They have like hundreds of thousands of employees. Let's say you have tens of thousands of employees with the same rating. You are duplicating this information that rating 8 pay at $10 per hour for, I don't know, tens of thousands of times. If you stick with the design like this. And that creates a bunch of problems. In other words, can we modify wage in only the first tuple of this instance? No, you cannot. In order to do that, you have to change the wage of all those with rating equal to 8. Does that make sense? And this introduces efficiency and anomaly problem. Let's say you want to adjust how you pay your employees, and you say, okay, from tomorrow, for rating equal to 8, I'm going to pay them a little bit more, $12 instead of $10. Now, in order to do that, you have to make tens of thousands of updates if you stick with the design like this. You follow this? So that's called update anomaly. And if in those tens of thousands of updates, something goes wrong with your database, you are screwed. You end up with inconsistency in your database. For some rating equal to 8, you pay them $10. For some rating equal to 8, you pay them $12. Insertion anomaly. What if you want to insert employee, assuming I delete those 2 employees rating at 5. Why? They leave your company. You no longer keep records for them. Does that make sense? Perfectly okay. You remove those 2 records. But what's wrong when you do that? Can someone tell me? Imagine you remove those 2 employees with rating equal to 5. Yes?
You lose the wage information.
Excellent. You lose the information how much you pay for someone with rating at 5. You lose that information forever. And you may say, what's the big deal of that? You may still get lawsuit. Right? If 2 employees with rating 5 leaving today, and you hire another guy tomorrow rating equal to 5, since you delete those 2 records, you lose the information. You are paying those 2 at $7 per hour. Now for this new guy you just hired, immediately after they have left your company, you pay them $8. You come up with some random number, you pay them $8. You know what? If this new guy are friends of those 2 guys that just left your company, you end up with a lawsuit. You follow my argument? Yes or no? Yes? I hope you at least see a lawsuit coming, right? If not, I don't know what to say in that case. I mean, maybe you got a really good lawyer, you got your way out. That's possible. Okay, you see that point? So that's what we call insertion anomaly and deletion anomaly, right? That's, insertion and deletion anomaly actually come hand in hand. These two go together. So what's the fix? What's a simple fix to all these issues? What's a simple fix to all these issues?
I think he said first,
Exactly.
make another table with just the
Make another table with this is what we call decomposing a relation. When you notice this, decompose them into two separate relations where you have SNLRH and another table called RMW. Meaning that you take the association between rating and wage per hour and store that in a separate table. Why this fix all these issues we have? But let's look at deletion anomaly. Let's say these two employees decide to leave your organization, you delete those two records. But because of this separation and decomposition you just did, you still have the information from rating to wage. You're still okay. What about update? Let's say you want to update all those rating at A instead of pay them at $10, you pay them $12 per hour. Instead of making tens of thousands of updates, now you just make one update. You fix this once for all. Do you see that benefit? Yes? Yes or no? So this is no-brainer. You should always do this. Assuming join is not too expensive. Because now, if I want to find out how much you pay, let's say the total compensation for an employee, which is hourly wage multiplied by the number of hours he or she has worked. In order to answer that query, what you have to do? You have to do a join between this table and the second table. It used to be you don't have to do a join. You select from this, you multiply hourly wage with number of hours you're not. It's a simple select over a single table. Albeit some simple arithmetic operation. But there's no join. Now you have to do a join between the two tables. That's the trade-off, right? There's no free lunch, remember this. In your life, in your database, I learned this lesson the hard way, right? I got caught up in this couple times. Then I learned my lessons now. Whenever there's something not even too good to be true, something like too good, like very good, there's something fishy about it. Right? So there's no free lunch, essentially. So you have to do a join. But as I said, join, if you do this carefully with the help of something called indexing structure, you can do this actually fairly efficiently, which we will talk about in the second half of the course, where we will dive into the kernel a little bit. But if you really want to know more about that, you should take my grad level data class. So far so good? So it looks like decomposition is our solution to this. But unfortunately, I should let you know that decomposition is not as trivial as this example has demonstrated. In this example, it's trivial. You just take these two keys, two attributes, make them a table by themselves, you're done. But there are more complicated cases. When you do this, you will end up with serious problems, really bad problems. I will talk about that later on. Let's focus on the discussion of functional dependency for the purpose of this course, for the purpose of this lecture. And we talk about those really bad cases that happen when you do decomposition later on. Okay. You had a question somewhere?
I have a question about when you do an insert into a table, can you nest a select?
Can you say again?
Can you nest a select
Nest
query?
a select. You mean do a bulk insertion? Yes, of course.
I assume.
Like insert into the archive database where the set of records you're gonna insert is select from applicant database where decision is known. Yes, we can do bulk insertion. But that has nothing, in bulk insertion case, you check each insert record one by one against functional dependency. So far so good? Now, I'm gonna backtrack a little bit. Now you understand what we said is, any functional dependency is a statement about all allowable relations. In other words, given a particular instance, you can check if a functional dependency has been violated or not. However, you cannot infer a functional dependency by looking at just one instance. These are two different things. Okay? Given a specific instance, you can check if something has been violated or not, but you cannot infer functional dependency by just looking at one instance. What do I mean by that? Well, let's look at this example. Right? Given this, you can check R determine W holds on this particular instance. And because in this instance, indeed, if rating values are the same, which value must be the same? Are the same, not must be, are the same, are in fact the same. So you can check if a functional dependency holds or not for a particular instance. But you cannot infer new functional dependency out of it. For example, imagine if I delete this record. Okay, now imagine that's the case. Okay, my functional dependency of R determine W still holds, right? I get it. By the way, I'm getting another instance when I do that. You follow this? Now, looking at this new instance, can you claim? Can I claim? Of course, you still have R determine W. You still have that. But can I claim, or for that matter, let me delete also this. This is not enough. So suppose I delete those two records, and I'm left with those three records. Now, can I claim R determine H, or H determine R? How many think you can do that? One? How many think no? Can you argue why you said no? You said no, right? Or you said no? Okay, can you argue why?
So, just reiterate, we're trying to determine R from H.
Yeah, R determine H.
Well, I think from here you can, but you can't always say you have a rating of 8 by 1 versus 3 hours.
The key, yes. He actually mentioned a really key point. You think about the definition function, the key statement is, any instance from that schema, you have R determine H for only one particular instance. You have this for one particular instance, which is the instance we're looking at with 3 records. But it says nothing about what if I modify my instance, but if I get another record. In fact, I can insert those two back, suddenly this violates your constraints. You may wonder, okay, fine. Then who determines I have this function dependency R determine W? Who determines I do not have this function dependency R determine H? Who decides that? Who? Well, that's just like the key constraint. Who determines the key of your schema? Not you. The applications, the business logic. If suddenly Congress passes a law tomorrow, no matter how clear the law is, it says in this country, if somebody got the same rating, or in reverse, whoever works the same amount of hours must be having the same rating. What is that, by the way? That's H determining R. And fundamentally, what is that? That's socialism. You agree with me? You don't look at the quality of work. I ask somebody to fix my house, 2 guys show up. Those put down 10-hour job. one got my house fixed. The other guy didn't even get my house fixed and make a big mess out of my house. But you have to pay them the same. The rating is the same. If you have H determining R. That's socialism. No? You don't think that's socialism? I mean, that's a simplified. I mean, I don't want to go into a politics. But from where I came from, I was born and raised in China. Now it's much better. In some area, China is more capitalism than US is, believe it or not. That's where the economy is doing really well. But when I was a little kid, like 2 or 3 years old, that's what people had then. That's when nobody works. No, people work, but I mean, nobody care about the work. Well, I do 10 hours, you do 10 hours. I build a rocket out of 10 hours. You write down 1 + 1 = 2 in 10 hours. We got to pay the same. Why I want to build a rocket? I would rather do 1 + 1 = 10 hours now. No? But if Congress does pass a law like that, then you have no choice. You have to write down a functional dependency related with H determining R. You follow my example? I hope you do. And keep that in mind when you vote next time. Like what functional dependency Congress is passing. Honestly, I think Congress is a bunch of lawyers overcomplicate things. I mean, instead of writing a bunch of functional dependencies, that's all you need to do. You write down this 100 pages document. You know why? To make it so hard to understand, so lawyers can charge really high fees, so they can make money out of it. That's essentially what's going on, guys. Okay? Good. So that's. So that's essentially the discussion we had so far. So there's another question here, how is related to the key? I think I explained this already, right? If it's a key attribute as you X, then that key attribute determines everything else in the database. Okay? We actually proved this. And in particular, functional dependency is a generalization of keys. For example, this R determine W, R is not a key, but R at least determines W. Why R is not a key, by the way? Because it's perfectly okay to have records with the same value on rating, and they have other attributes that may have the same values, such as wage, and they have some other attributes may not have the same value, such as name. So rating obviously is not a key. It's not even a super key. But it doesn't prevent you from having that dependency of R between W. Okay, so that's the relationship to the keys. All right. Now, finally, why, in this example, right, R determine W is causing us a lot of problems. That's why we decided to decompose that into 2 separate relations. But X determine W is not. Social Security determine wage. Why we have that dependency, right? But why that doesn't give us any problem? Right? Because of the key and S is unique, and without that, no 2 records can even have the same SSN value to begin with. So of course it cannot give you any problem. So let me give you another example before I join today's lecture. Right? I said functional dependency has a strong tie with schema design, refinement, and ER. Let's look at ER diagram as an example. Let's say I have this ER diagram. It looks perfectly okay. Where lot is where you park. Now this looks perfectly okay, right? Because the employee can park without anything being said. The employee may park anywhere in any parking lot. That's what essentially this design is saying, right? You work for some department, you can park any lot. Now let's say I want to organize a little bit. of my organization, right? If you go to Microsoft, Google, they typically have these rules. If you work for this department, you park in front of building 31, right? Because that department is working in building 31. You cannot park in building 106. So, does that make sense? Make perfect sense, right? So suppose you have, so now that's your schema, right? You have a one, by the way, you also have a one-to-many mapping, meaning that an employee works for only one department, cannot work for more than one department, but a department may have multiple employees working for that department. So you end up with a schema like this. Workers SNLD SI, and department has DMD. Why? You take the DID and place that into the worker table, you capture the fact that he or she works for that single department. You do not have to create a table for that work scene relationship set, right? For one or one-to-many, you do not have to create a table for that relationship set. So far, I mean that's basic, right? But now I hope that's basic to you. Is this design a good design? So far, it's good design. But let's say good design implies lots, parking lot associated with worker. In other words, anyone can park anywhere. Does that make sense? Now, whoever asks you to design the data come back and tells you all employees working in the same department must park in the same parking lot. That's like somebody writing a law in Congress proposing this deal. And believe me, they will make it even more complicated than this. But let's say you have a really good conscious congressman that this is as simply a burden as he or she can come up with. But if you're the database designer, you would say something like, oh, what you mean is D determine out. That's it. No ambiguity whatsoever. A case can be determined automatically in your court. You don't need lawyers. Just run the deduction, look at the functionality, you're done. And again, D determine out, that's what you're saying, right? If you have the same department value, your log value must be the same. What if you have different departments? Can employee from different departments park in the same lot? Huh? Yes or no? Yes, because you said nothing about it. And that's perfectly okay. Imagine you have a building with two departments working in that building. Both departments should be able to park in the lot in front of that building if the lot has enough capacity. So all I'm saying is D determine out means that if you're in the same department, you park in the same lot. If you're from different departments, you may or may not park in the same lot. But if that's the case, what's the implication to your ER design? Is this still a good design? If that's the case, lot should really be an attribute for department than employee. Why? Because you put lot as attribute of employee, you are duplicating that value, that association multiple times for all employees from the same department. Rather, if you put lot and the department, you store it once for all. You fix insertion, deletion, update anomalies. So your schema should be changed back to. So, using the earlier argument, we should do a decomposition like this, but even better fix is really this, rather than decomposing it. That shows you the challenge and how tricky it is to function this, right? And with that, we can see on Wednesday, okay?